Okay, we're going to look at a chi-square test of independence. And so basically what we have is if you have a stress fracture in your foot, we're saying, would it be better to have surgery? And so these are the people that had surgery, success, failure, or would it be better to have a weight-bearing cast or non-weight-bearing cast for 6 weeks or non-weight-bearing cast for less than 6 weeks? So we're going to still do our whole chi-square where we do our observed minus our expected squared over our expected. So that doesn't change. But in this case, we're given a contingency table. Okay, so we have rows and columns based on this information given to us. And to find our expected, we have to take the row total times the column total divided by the grand total. All right, so that pretty much means, I guess I need to get some totals here. So I'm going to call that total and call this total. And I'm going to sum this row, that row. So I'm just doing a sum. And I can copy this straight down. And now I'm going to sum these columns. So sum this column, and then I will copy that formula straight across. And so all this does is just simply give me my totals that I'm going to need to find my expected frequencies. Okay, so to find the expected frequency thens, and I'm going to kind of cheat, and I have another spreadsheet, I'm going to copy and paste that. This is my formula, which you see over here. And I want the same categories, so my surgery, weight-bearing cast, and so on. So what I do is if you look either at this formula over here or looking at this, it says equals, open a parentheses, the row total, which would be this value, times the column total, which would be that value, divided by the grand total. Now there's not going to be a whole lot of copy and pasting I can do here, but if I think about this and I want to copy this to the cell next to it, okay, my failure, notice the row total will be the same, so I'm going to make that an absolute reference that I've talked about before, that I want to be sure it copies that same row total. And then I always want to copy the same grand total. Okay, so all I want it to do is move over from this column total to that column total. So I want the B6 to become C6, so that's okay. And now I can basically do the same thing straight down, but then I'm going to be able to copy it over to the next column. So I have to kind of do this for each one. So this one is going to be this total row, and the row is going to stay the same because it's going to be the row for weight-bearing cast. And then I'm going to multiply it times this first column, close my parentheses, and then divide it by that total. I'm going to absolute value it again. Remember, I'm pressing F4 when I get those dollar signs. I mean, you can type $D, $6, but again, I'm lazy, so I just press F4. All right, so then my next one equals, where am I at? I'm on this row, so I need, no, that row. So I need that value, and I want my row to stay the same. I need this column, but my column is going to change when I copy it, and then divide by my total that's not going to change. And then finally, my last one, I want this row that's not going to change times this column that is going to change, 1 over, divided by my total that's not going to change. So we did have to type a bunch of these in here, but now I will be able to take this and copy it straight across because, again, the only thing that I told it not to change or to change was my column. Okay, so I got all that. Now I'm ready to find my chi-square. How do we find the chi-square, same way we've been doing it, is the observed minus the expected squared divided by the expected. Well, the observed is the data that was given to me, minus the expected is what we just calculated, and then I want to square it, and then divided by the expected. All right, so observed minus expected squared divided by the expected. And I probably should be a good student and get all this information back here. So same thing. All right, this one so nicely I can completely copy to the right, and then I can copy it down because this formula is actually changing. Okay, you can, in other words, you can double click on one of these and you can see that it's picking the right values. All right, so I have all of that. How do we find our chi-square total? We sum. So I want to now sum all of my values that I just found. So I'll do an equal sum, and I want to add up all of those values. So I highlight them all, and I get my chi-square test statistic. And of course we can see this is high, so probably going to be a high p-value, right? So chi-square test statistic. And now I'm just back to what I was doing in my other videos where I find the p-value, I give you the significance, and I give you a critical value. And we're going to have something a little different with degrees of freedom. So let's do the p-value first, which is the same formula we've been doing over and over and over. So the chi-square distribution, right till, click on my value, and now it asks for my degrees. Sorry, I'm going to start coughing. My degrees of freedom. So the problem is, so I need to get out of this because I need degrees of freedom right here. This one has a little bit different of a degrees of freedom. How you find the degrees of freedom is you take the number of rows, 1, 2, 3, 4, subtract 1, times the number of columns, 1, 2, and subtract 1. And so then my degrees of freedom, and I can either write that as a formula, so equals 4 minus 1 times 2 minus 1. My degrees of freedom will be 3, because 4 minus 1 is 3, 2 minus 1 is 1, 3 times 1 is 1, 3 times 1 is 1, 3 times 1 is 3, and so that's my degrees of freedom. So now I can go back and find my p-value, which is my chi-square.dist.rt, my chi-square test statistic, and then my degrees of freedom, which is right there. And as we can see, as we've said before, when you have the E minus 12, that says you're going to move this decimal 12 places to the left. So that's a very, 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 very small p-value. So definitely going to reject the null, which let's bring that down here so we can still see it. So we're going to reject the null because my p-value is way less than my significance. So certainly it looks like the success and treatment are dependent. So depending on what treatment you use, looks like you're going to have better success. And then just to complete this, let's go ahead and get our critical value, which we already know our chi-square test statistic's going to fall in it. But let's go ahead and get it. So then my probability, comma, my degrees of freedom, close my parentheses, and again, comparing these two values, I can definitely see my chi-square test statistic is way beyond my critical value. So I'm going to reject the null and actually say that the success and the treatments are dependent.